Well, it's a pleasure to be here. So I'm going to try to convince you that storage matter, and we can do a lot better in storage, and somehow the slides don't proceed. So I'm a professor at Georgia Tech, but I'm also a co-founder of the company, Sila. And so material technology are going to define the future of lithium-ion batteries. Why is that? We know that the battery determines the EV performance, but what sometimes people don't fully realize that materials that go inside the battery, they define all the battery key performance characteristics. In essence, they define the vehicle range, acceleration, charging time, safety, and cost. And so if you look at the intercalation type lithium-ion, the one that was invented 30 years ago and commercialized, it is true indeed that initial price decrease was quite substantial. Doesn't work this way. But we would also see that in the last 10 years, if you look at the commodity lithium-ion batteries, there was a price stabilization. So nowadays the price is about $100 per kilowatt hour, and it's probably going to increase this year because of the increase in commodities. Furthermore, if you look at the performance, you also see that performance is saturating. It's very hard to squeeze any more juice out of batteries. Furthermore, if you look at other issues, there are multiple supply chain issues. All the high-performance batteries that you use in electric vehicles, they comprise nickel and cobalt. And those are not distributed uniformly around the globe. And furthermore, there is not enough nickel, not enough cobalt. And we wrote this review article quite a few years ago and predicted that by 2025, 2035, there will be a significant mismatch between supply and demand for nickel and cobalt, and the prices for these metals are going to go up. But now, because of the war in Ukraine, just this year, the price raised by over 2x. And as a result, the price of lithium-ion battery is going to increase. Furthermore, there are major reports on safety, health hazards, pollution violations in developing countries mining these minerals. So what do we do about it? Well, there is a new class, so-called conversion materials, that can set a new performance limits. That can give you lithium-ion batteries that will be maybe half the size and 3 times lighter, potentially enable electric aviation. But in addition to that, you can also have significant cost reduction. So in a decade, the price can go down to below $50 per kilowatt hour. In 2 decades, hopefully below $30 per kilowatt hour. So, but somebody needs to develop this technology and scale. And so this transition is not trivial. So how do we go about it? At Sila, and this, oops, go back. Yeah. So at Sila, we rely on 2 foundations, 2 pillars. First, we rely on deep scientific advances to make this transformation possible. But we also rely on large-scale industrial engineering to make this transformation happen at scale and matter. So some of you probably heard about lots of scientific advances in battery technologies every day. But all these advances only matter if they materialized in real product you can buy in the market. And being in the market is ultimate validation of technology. It separates sometimes wishful thinking from being the real deal. So last year, some of our partners disclosed that they're using our technology, Sila technologies, new materials, to power electronic devices, in this case, Whoop Fitness Tracker 4.0. So they developed batteries that is much smaller, that is more powerful, now has many more fitness trackers, looks more elegant, still has 5-day battery life. And so it's a very nice demonstration, just development of these revolutionary materials in batteries can significantly improve products. Maybe more relevant to this case, another example. So another our partner, in automotive space, Mercedes-Benz disclosed it's going to use our technology to power G-Wagon electric vehicles. And it is quite a remarkable electric vehicle. It can go up the hill in 45 degrees angle. It has 4 electric motors independently operating. It can rotate around its axis. Just an amazing car, even though it's SUV. And so in every generation, the Mercedes picks the best technology to use in their vehicles, and therefore it picked Sila. So Markus Schreifer, Mercedes CTO, mentioned that the partnership with Sila was essential for them to build the most desirable electric car. So well said. So are we going to get ready to this enormous scale that is required for batteries in transportation, in grid, and other applications? Absolutely. So the Sila technology is ISO certified, and we already built in a very large factory, over 600,000 square feet, in Washington State, in the United States. And it's going to be powered, by the way, by 100% renewable energy. So no fossil fuels consumption here. So at full scale, it's going to provide enough materials to power 2 million electric vehicles. And so to go to like 1.5 billion electric vehicles in the world, you have to produce eventually about 100 million electric vehicles per year. So we have to start now to get there by 2050. And the first operation starts in 2024, and the blueprints are going to be used in other factories. Maybe in Europe, maybe in Spain. And so there are multiple advantages to end customers, there are multiple advantages to device producers, but there are also advantages of lithium-ion battery manufacturers of using this advanced technology that increases the energy density of lithium-ion batteries. Because without any changes in equipment in this case, they can improve the output of the factories. So essentially, without additional investment, without hiring more people, if they would say produce enough batteries to power, let's say, 1 million electric vehicles per year, with new technology, let's say, provides 25% more output, they can now provide enough batteries for 1.25 million electric vehicles. As a result, you have reduced depreciation, you have reduced consumption of energy. If it's not renewable energy, you have reduced consumption of CO2. So thank you so much for your attention.